Good night, everyone. My name is Deangelo Brown. Today, I'll be introducing our topic AI and machine learning based intrusion detection systems. With the growth of 5G, LOT, and cloud computing, billions of devices are now connected. While this improves communication, it also creates more opportunities for cyber attacks. Traditional intrusion detection systems monitor network traffic, but they also rely on signature attack signatures, which makes them ineffective against new threats. AI and machine learning help solve this by learning patterns and detecting attacks, even the ones the system has never seen before. The main issue with traditional IDS is that they depend on known attack patterns. This means they often miss zero-day attacks and produce false negatives where real threats go undetected. They also struggle to adapt to constantly changing network environments. Because of these limitations, we are exploring how AI and machine learning can improve detection by identifying unusual patterns and catching hidden threats. Our research focus will be mostly focused on four main areas. It'll be performance, scalability, security, practicality. These areas help guide the development of better intrusion detection systems. First, it'll be performance, improving accuracy while reducing false alarms. Scalability, handling large amounts of data from modern networks. Security, making systems resistant to attacks. And practicality, ensuring they are cost effective and easy to use. An intrusion detection system, or IDS, it monitors network traffic to detect suspicious activity. It works by watching traffic, identifying threats, and alerting administrators or blocking attacks. There are two main types. First, it'll be signature based IDS, which detects known attacks. And second foremost, anomaly based IDS, which detects unusual behavior. Each type has a strength, but also a limitation, especially when dealing with new threats. Traditional IDS systems have several weaknesses. They rely on known attack signatures, so they miss new or evolving threats. They also struggle to adapt to new environments and require constant updates. On top of that, they can't keep up with high speed and large volume of data in modern networks like 5G and cloud systems. These limitations reduce their effectiveness in today's cybersecurity landscape. AI based intrusion detection systems improve on these issues. They learn what normal network behavior looks like and can quickly detect anything unusual. This allows them to identify zero-day attacks and reduce false alarms. They also continuously learn and adapt, becoming more effective over time. Because of this, AI based IDS are better suited for modern and high speed networks. Machine learning is what makes AI based IDS possible. It analyzes past network data to learn patterns of normal and malicious behavior. So this helps distinguish between safe and potential threats. As a result, it can detect new and evolving attacks more effectively than traditional systems. Now I'll pass it on to my individual group member, Jose, to continue with the more advanced techniques.
Hi, my name is Jose Olano, and I'm going to be continuing our presentation on AI and machine learning-based intrusion detection systems for telecommunications networks. Now that we understand why traditional IDS falls short, let me walk you through how machine learning changes the game. ML works by learning from historical network data, both normal traffic and known attacks, to build a model of what normal behavior looks like. When something deviates from that baseline, it flags it. What makes this powerful is that ML understands attack behavior, not just attack names. So when a brand new threat appears, it can still recognize that something is wrong, which is exactly what allows it to catch zero-day attacks that would completely bypass a signature-based system. Deep learning takes this further with specialized neural networks. There are three key models here. CNNs are the spatial experts. They can network data for structural patterns that indicate an attack. RNNs are the timeline trackers. They analyze sequences of events over time, catching threats that unfold in stages rather than all at once. And LSTMs are a specialized RNN. They remember patterns over long periods, making them ideal for slow, persistent attacks that try to stay invisible. Together, these models deliver sharper accuracy, catch stealthy threats, and are built to handle the massive data volumes of 5G and cloud environments. This table puts it plainly. Traditional IDSs is signature-based. Static generates high false positives. It struggles under heavy traffic and requires constant manual updates. AI-based IDS adapts continuously, detects zero-day threats, reduces false alarms through pattern recognition, and scales efficiently across 5G, IoT, and cloud systems. In every measurable category, AI-based IDS outperforms traditional methods in modern network environments. One of the most important concepts from our literature review is spatial-temporal feature extraction. Traditional IDS only asks, what is this packet? Deep learning asks, what is it and when and where is it happening? By analyzing both dimensions simultaneously, these systems uncover threats that would otherwise stay completely hidden, especially in advanced persistence threats, those slow, long-running attacks that deliberately stay below the radar for weeks. The research consistently showed that combining CNNs and RNNs together produces significantly higher detection accuracy and far fewer missed attacks than any single approach alone. 5G networks generate enormous traffic volumes, support massive numbers of connected devices, and require ultra-low latency detection. Cloud environments add another layer. Data is constantly moving across distributed servers, demanding real-time monitoring everywhere at once. AI-based IDS handles this through transfer learning, adapting models trained in one environment to another, and distributed IDSs, spreading detection across multiple nodes for better scalability and reliability. The key finding from the literature, cloud and 5G environments benefit the most from AI-driven security, and they're exactly where traditional IDSs fail hardest. AI best AI-based IDS is not without vulnerabilities, and the most serious one is adversarial attacks. This is where hackers make subtle, often invisible tweaks to their traffic specifically designed to fool the AI, making dangerous activity look completely harmless. The result is a blind spot where real attacks slip through without a single alarm. Research confirms that even the best AI systems have exploitable soft spots. The defenses are adversarial training, feeding the AI examples of these tricks during training so it learns to resist them. Stronger model architectures that are harder to manipulate and continuous retraining so the model never goes stale. This remains one of the most critical open challenges in AI-based network security. Thank you.
Hi, my name is Michael Phoutrides. I'm doing slides 14 through 18, and I'm going to share my screen with you right now. All right, so hybrid machine learning and deep learning models in IDS. What are hybrid IDS models? The best of both worlds. These systems mash together machine learning and deep learning to get a more complete defense. Teamwork. Usually the machine learning side handles the heavy lifting of sorting and filtering data, while the deep learning side dives deep into spot complex patterns. So why should you go hybrid? Better stats, they're more accurate. You work smarter, not harder by filtering out the junk early. And just on an aside, There's a lot of hallucinations and things happening with AI. So this is a way to fix that problem. And so total balance, they find the sweet spot between being fast enough for real-time use and smart enough to catch sneaky threats. What the research says. So top tier performance studies show hybrid models consistently beat out standalone systems, tougher defense. So they can withstand a bunch of different types of cyber attacks at the same time. Speed and precision, you don't have to choose. They improve how fast you catch threats, how accurate. So they shine in 5G and cloud, proof for handling massive fire hose of data and high speed or large scale networks. And the Internet of Things devices, IoT devices, great for smart gadgets that don't have a lot of processing power, but still need solid security. So moving on to slide 15, AI-based intrusion detection in 5G networks, the 5G landscape. Total speed and scale is, 5G is incredibly fast and connects everything from your phone to smart city sensors, medical devices. Zero lag, slicing the network can carve out slices of the network for specific needs. New security headaches, more doors to kick in because so many more devices are connected. There are more ways for hackers to get inside, and attacks happen really quickly. So that's the don't blink part. Too complex for old tools. Things are complex, things are moving really quickly, so traditional security systems just aren't fast enough. And how AI saves day in 5G, micro monitoring, all AI can watch the network slice individually to make sure a breach in one doesn't tank the others. Real-time radar. It spots weird behavior across the entire distributed network as it happens. Built for speed, deep learning models are specifically designed to handle the fire hose of 5G data without slowing things down. And here's what the research says. So there's a huge improvement because the data shows that AI is a game changer for security in 5G. And then using distributed learning, where different parts of the network learn together, makes the system much more reliable. So different nodes connecting the system and making it more reliable. And need for speed. The biggest takeaway is that these AI models have to be lean and fast so they don't ruin the low latency benefits of 5G. And then AI-based intrusion networks in the Internet of Things, IoT networks. The IoT landscape connects to everything. Internet of Things, obviously, we're talking about massive web of smart gadgets, fitness tracker. I've even heard of smart refrigerators and things like that. So brain power issues. Most of these devices are tiny, don't have much muscle when it comes to processing or memory. Easy targets, but because they're so small, they usually don't have built-in security, making them low-hanging fruit for hackers. You wouldn't think that uh, your refrigerator registration could lead to a data loss and data stealing from hackers, but it can. Security struggle, the weakest link, since the individual devices are wide open, they're easy to hack and often get recruited into botnets to attack others. Finding the needle, monitoring is a nightmare because you're dealing with huge volume of tiny data bursts from thousands of sources. Old tools won't fit. Traditional security software is way too heavy to run those limited gadgets. It would just crash them. How this AI steps in. Instead of putting security on every single device, we put an AI-powered gatekeeper at the network edge or gateway. And the central system watches the traffic through all your devices, checks the behavior, and because it's low weight, slimmed down, these ML models are specifically designed to be fast and efficient without eating up all the power. And the hybrid approach, using a mix of different AI techniques, helps keep the system accurate without slowing things down in the network. And then AI-based intrusion detection in cloud networks, cloud network characteristics, large-scale distributed computing environments, continuous flow of high-volume data across servers, security challenges in cloud systems, large attack surface due to multi-tenant environments, data is consistently moving between distributed nodes. The role of AI-based IDS in cloud environments enables real-time monitoring of distributed cloud traffic, detects anomalies across multiple servers or nodes, and federated learning advantage trains models across multiple systems without sharing raw data, improves privacy and security. And the challenge, dataset imbalance in IDS. What is dataset imbalance? The rare event reality. In the real world, 99.9% of network traffic is totally normal. Actual attacks are like finding a needle in a haystack and are extremely rare. Why it's a problem? The lazy model, if 99% of the data is normal, then AI can get 99% accuracy just by guessing normal every single time. It looks smart on paper, but it's actually failing its only job, which is very funny. The bias trap, the model becomes heavily biased towards what it sees most. It starts to treat rare attack patterns as weird but harmless noise rather than a threat. Impact on IDS performance, fake success. High overall accuracy scores can be misleading. You might have a 98% success rate, but if that missing 2% represents every single attack attempt, the system is useless. Obviously, you don't want any attacks to get in, so 98% is great, but that doesn't help you if you're that 1 or 2% that gets attacked. So, common solutions, smote or oversampling. using algorithms like SMOTE to artificially create synthetic attack data. It's like creating practice targets for the AI, so it has examples to study. I kind of look at it like your immune system and how it kind of targets certain things with certain antibodies. It's kind of a similar way. And we'll move on to slide 19 for Stephen.
Good afternoon. My name is Steven Herrera. My Panther ID is 6544735. And today I'll be presenting slides 19 through 23 of our AI-driven IDS presentation. Now, to begin, we had already talked about the different challenges, and I'll continue talking about that. Specifically, the computational overhead in AI-based IDS. Now, the main issue here is the computing cost of having to run these AI-driven models. Now, one demand is the resource demand. This is the brain power that is needed to train the AI and have it monitor traffic in real time. Things like CPU, RAM, and time, especially the RAM, which is now like very expensive in today's day and age. Now, the problem. Here, deep learning models are heavy. They need expensive hardware like GPUs, which have also risen in price a lot and can cause latency if the AI thinks it's too slow, which then slows down the network itself because it can't sift through different intrusions. Now, the Internet of Things and 5G environments have a lot of data volume, and small gadgets don't have the memory to run big models that can take care of all this data. And 5G networks can't afford the lag because then intrusions come that it can't sift through. What are some solutions though? One solution could be model slimming, designing a lighter AI that uses less math, does the same job as a higher trained AI model could be a solution to it. Another solution could be edge computing, spreading the work across the network so one server doesn't take all the brunt of the intrusions can help lighten the load between different models. Another one could be the hardware boost. Using chips built for AI, like TPUs and GPUs, can help speed up the processing power of it and require less of other parts, like maybe less RAM, will have more space in your GPU. Now, another solution could be smart filtering. This is using a simple model to clear the easy traffic, the easy intrusions that come through the network, but then use the higher model and leave the heavier data loads for that model so they can detect and sift through uh, more complex malware attacks. Now, beyond the heavy processing demands, AI-driven IDS are also highly vulnerable to adversarial attacks. Well, what are adversarial attacks? Let's see. Another final challenge are these adversarial attacks, which is basically where hackers slightly tweak their traffic to essentially gaslight the AI and make it think that safe traffic, a malware that they put, is actually safe, and the AI will believe that, oh no, it's fine, and it'll let it through and it'll mess it up. But they can make blatant attacks. Thus, they make blatant attacks look like totally normal activity to the system. Now, another struggle would be the scale struggle. It's hard to keep an AI fast and accurate when it's dealing with so much data volume that's seen in 5G, Internet of Things, and cloud setups. Too much data can simply overwhelm the AI engine and make its job less efficient. Now, in a 5G environment, every millisecond counts. Updating these models and training them to keep up with new threats without slowing down the network is a very difficult task to do, and one that's very rarely done. Now, another challenge is staying sharp. AI isn't just set and forget. No, you have to retrain the AI with new quality data sets, manage the AI, make sure that it's running smoothly, and provide maintenance to the AI so you can make sure that the AI is doing exactly what it was tasked to do. Now, if you don't do this, its performance will slowly rot, making it useless to new, evolving hacking strategies. Now, another area that AI-based intrusion detection systems are going towards is the future. Now, where is it going? Well, one of those is total autonomy. we're now moving towards systems that don't just alert humans, rather they take action. The future is an IDS, an intrusion detection system that can spot, analyze, and neutralize a threat instantly on its own without anybody having to actually manage the device, the AI-driven model, and allowing it to protect the network. Now, another thing is deep learning is getting smarter. Newer neural networks are able to sniff out more complex and sophisticated intrusions that other models simply just can't do it. And they can do this with precision and avoiding false positives, which is when false alarms occur. Now, instead of separate tools, future security will be a unified and single layer that covers everything from your smart devices in your Internet of Things to 5G towers and massive cloud servers that corporations use. Now, another future direction is federated learning. This is actually a really good game changer, and it allows different companies to teach a shared AI model about new threats without ever actually having to share their private sensitive data, which is really plus for the corporations because they don't want their competition to gain an edge on them. Now, as a result of all these directions and advancements in AI, hackers are also trying to um, write smarter malware so that their intrusions can get past these AIs. And for that reason, they're trying to evolve to just catch AI generated attacks and create those. Now, what's our conclusion? What have we learned? Well, we've learned that the AI advantage is very significant. AI and machine learning have completely changed the game. They aren't just better at catching known viruses, rather, they're actually smart enough to sniff out zero-day attacks, which is basically a brand new threat that hasn't been encountered yet, that have no previous record. Now, we're leaving also old tools behind. Traditional security is static and gets overwhelmed easily. AI thrives in a fast paced world of 5G and cloud because it adapts on the fly and actually gets the job done better and more efficient as it processes even more data than older models. Now, we also discussed some of the challenges that we faced. For example, 99% of traffic is harmless, so it's hard to train an AI to stay focused on the rare, dangerous needles in a haystack that might actually be, a malware attack against a network. Another challenge that we faced was the power bill. These systems are very heavy. They need serious computing muscle and energy and can be expensive and sometimes slow down the very networks that they're trying to protect. Now, another challenge that we encountered was that we have to watch out for those adversarial attacks, which is basically where the traffic passing by seems safe, but in reality, it's actually not. And this is where the hackers try to use that to trick the AI into thinking that it's just safe, let it pass. Now, the bottom line is that the AI based security is no longer optional. Cyber attacks are evolving too fast for human written rules to keep up. And while we still need to work on making these models faster and harder to trick, they are the only real way to detect them, to defend a modern connected world in these environments. Now, our references that we use across the presentation um, is based on multiple peer-reviewed sources, primarily from uh, IEEE journals and conference proceedings. These studies cover areas such as deep learning techniques, hybrid models, adversarial attacks, intrusion-based detection systems in 5G, Internet of Things, and cloud environments as well. Using these sources helped us ensure that our findings was accurate, reliable, and based on current advancements in the field, as seen as soon as 2025. Thank you for your time and have a great day.